Okay, so on the agenda for today, you have the notes. We have an activity. For the activity, you need to watch the instructional video that I posted in the formative. Otherwise, you are going to struggle and not know what you're doing. I'll touch on it a little bit at the end of this, but make sure you watch that. After you watch that, if you have any other questions, if you want me to look over your stuff before you submit it, just hop on a Zoom, email me, one of the two things, or even class tag. I'll get back to you as soon as I can. You also have the quiz today. Remember, with quizzes, you can use your reference tables and your notes, and it's supposed to be just you. I do not want you copying or working with somebody else. Quizzes and tests are by yourself, no one else. Okay, so I gave you a copy of the notes. All you have to do is type in this one. So an earthquake happens. We're looking at S&P waves, by the way. An earthquake happens when two plates slide past each other, get stuck, pressure builds, and there is a pop, which is an earthquake. And you can see that right here. So it's pushing, pressure, 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 pressure. Finally, it pops. And that's when you get the really, really big earthquakes. The spot where it happens below ground, so like where the actual pop happens, is called a focus, with a spot at the surface called the epicenter. Now, why do we need to know where an epicenter is? Well, that's because that's where the most damage is. That's where people will be trapped, where you want to send rescue trucks and help and aid. All right. So when an earthquake happens, there are two types of shock waves that run out from the earthquake, or the epicenter. Two that you do need to know. The first one is called a P wave, which is a primary wave. So you're going to notice they're going to start the same. P, primary. A primary wave travels fastest and can travel through both liquids and solids. This type of shaking from the P, this is the top one. It's kind of like a compression. So it's like a back and forth. So you can see like it's going back and forth. It's like an accordion pushing like this. Push and pull, push and pull. You could even push, put down, push, and pull, which is actually better for primary and P waves. That way you get in the habit of thinking if it's a P wave, it's primary, push, pull. And right here, I wanted to show you this. So a P wave, it can travel through liquids and solids. Remember, the outer core is liquid, and everything else is considered solid. So looking here, because the Earth is round, it can the waves can curve. They can do a curve. So right here, you have this curve, and once it hits this, because it hits a liquid, it deflects a little bit and it curves again, and then it curves down here, and then you can read the P wave right there on the other side of the world. And then right down below, it can go straight down through. So P waves can hit everything. It can go through solids, liquids. It's awesome. Well, not awesome, but more destructive. The other type of wave, which is this one right here, that is called an S wave, or a secondary wave. So you got P, primary, push and pull. Now you got S wave, which is secondary, and it's slower or slowest and can go through only solids. So S wave, second, slow, solid. And here's the thing. It looks like a snake. And look at this right there. What type of wave did this damage? That's an S wave. Looks kind of like a snake. So S, second, slower, solids. Snake-like pattern. All right, and then you can see the S waves right here. It will not go through any part of this liquid outer core. It can't. It just can't. It stops dead. It's like it's not there anymore. So this one just barely touches and it hits right here. And then you have this shadow zone where the S won't go. Like the S cannot go, only the P waves can go, because that's where the the outer core is. All right, so the P and S waves, they are measured on this device thing right here, which is called a seismometer, not a seismograph. This right here, where my face is covering, this right here, that's a seismograph. It's the actual readings where you have the little squiggle lines. A seismograph is the readings. A seismometer is the machine, the instrument, the device that measures the S&P waves. Okay, so we're going to do a little bit of work looking at page 11. So we've looked at page 5, we've looked at page 10, now we're looking at page 11. So we use the P and S waves to figure out the epicenter distance, how far away. Remember, we got to figure out where that epicenter happened so that we can get help. So how do you find the distance? Distance is found on page 11, like I said, of your reference table. Along the bottom of this page, you have the, sorry, that's darn bar keeps popping up. The epicenter distance, it's underlined in blue right now, which are in the thousands of kilometers. How do I know it's the thousands? Well, these, like 1 would be considered thousands. And how do I figure that out? It's 10 times 3, 10 to the third kilometers. So if you were to write that out, it'd be 1, and then you'd have, like a 1 would be right here, and you'd have to do 3 bumps back. Or yes, 3 bumps back, like make the decimal move over 3 times. So 1, 2, 3, you're going to add 3 zeros. It's 1,000. So each of those numbers represent 1,000. And between each interval, sorry, that darn thing keeps popping up. Each interval, is 200 kilometers. Right there, that little line that just popped up. Each one of those are worth 200 kilometers because there are 5 lines. So 1, 12, 14, 16, 18, 2,000. So that's how you figure that out. All right, so now that we've looked at that side, I'm going to move my face right here. Along the y-axis right here, you have travel time. See, travel time. And it's in minutes. So each of these right here are going to be a minute. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 24 minutes. There's only 3 lines. 1 minute is 60 seconds. If I've got 3 lines, all I have to do is 60 divided by 3. That is 20-second intervals between each whole minute. So here's what I'm going to suggest for you guys to do right now. I told you about the epicenter distance, how these are worth 1,000. On page 11, right here, like towards the bottom, I would write down right next to this 1,000. So you know that it's worth 1,000. And on, like, you could even look to right here, like that first line, you could put a little line down and put 200. And on the side right here, you can make it so that it says, you know, that's a minute, but each of those little lines you could put a 20. So it'd be 20, 40, next minute, 20, 40, next minute, 20, 40, next minute. So the general trend of this graph is, looking just at the graph by itself, is the farther the epicenter distance, the greater the distance between the 2 waves are. So you can see there's a greater distance between the S&P wave. The longer it takes, the farther away you get. All right. So I'm going to see if I can pop over to the formative real quick. And I will show you what you're going to be looking at. So when you click on this, you're going to have this right here. It's about 7 minutes long. You most definitely should be watching this. I can't stress how much you're going to want to watch this, because it will explain how to do everything. So the first question you have is, if a P wave traveled 7 minutes, how far away is the earthquake? You are going to be using this reference table page 11, on this. So you can swap back and forth between this and the note. Well, yes, the notes, because I put it on the notes. If you don't have it on the internet, which you should be able to look it up, and you can save it to your drive. So you always have it, or you have it in hand, because I sent these out. I sent your reference tables out the beginning of the school year. If you still do not have one, you need to let me know so I can get you one as soon as possible. But you should all know that I did have them sent out. They were sent out via the mail the beginning of the school year. You should have one. If you don't have one and you didn't tell me about it, that's a problem. We're like halfway through, more than halfway through all of the units, and you haven't had one for all these quizzes and tests, which makes it kind of, how do you get your information? So make sure you're using reference table page 11 to get these this activity. It's 10 questions, all multiple choice. And then after this, what you should do is complete the quiz. It is also on GoFormative. Once you complete the quiz, submit, and you are done for the day. So there's 3 things. You're going to watch this Edpuzzle and take notes. You're going to do the assignment, the activity, watching this video that I have attached with it. Trust me, it will help you understand what to do. And then you're going to take the quiz. That's 3 things. That's it. If you have any questions, please feel free to reach out to me. During school hours is the best, because I am on my computer at school and I can get to you. Outside of school, it's hit or miss. Class tag is the best way to get a hold of me outside of school hours, which is 4 o'clock and on. Make sure you're Zooming. It is required. You Zoom 1 time a week with me. It is part of your grade. Progress reports are going out today, so there's a heads up on that. Besides that, I hope you guys have a great day.